Students, in this video, I am going to go through some exercise questions on solving exponential equations where either side of the equation will have expressions with different bases. All right, so I've been building up a lot of hype, leading up to this lesson where I'm going back, I don't remember how many lessons I gave you guys this one problem where it was 5 is equal to 2 to the x, where now we have enough information where we are able to solve such type of problems. Let's take a look, okay? I'm actually not going to do question 1 yet. I'm going to do this guy first, okay? So this is very, very, very similar to that baby question I gave you guys going back several lessons ago. And the attempt is we got to solve for what the unknown is, okay? And right now it's clear that 81 and 15, they're clearly not going to be of the same base. So what we're going to do, recognizing that logarithms is the function that is the inverse of an exponential function, we're going to apply logarithms. However, we're not going to apply logarithm of base 15, but instead, we're going to be applying logarithms of either base 10 or base e. Actually, if you think about it, there's we can apply logarithms of any base, but we're going to be using log base 10 and log base e because those are the only two logarithms that we have known values for in our calculator. Okay, our calculator can certainly compute other kinds of logarithms of other bases, but those are the only two that are readily accessible that are already pre-programmed. Okay, so let's take a look. I have 15 to the negative 4r is equal to 81. What I'm going to do is I'm going to use log base 10. Remember, if I don't write a base, it's by default 10. And I'm going to take the log of both sides. And why am I doing that? Well, the reason is I want to isolate r, right? Which rule was it that allows us to that allows us to take the exponent and bring it out in front and turn it into a coefficient? Oh yeah, that was the power rule for logarithms. So the exponent right now is negative 4r. If I apply the power rule, I'll end up with negative 4r log of 15 is equal to log of 81. So therefore, if I were to isolate r, all I got to do is divide both sides by negative 4 log of 15. Divide both sides by this. So look at this. I now have the answer that I was looking for. And just to follow the instructions, it says to round our answers to the nearest 10,000ths, right? So let's do that, okay? So log 81 over 4, negative 4 log 15. So I want to go into my calculator. I want to type in log of 81 divided by negative 4 log of 15. So I have my answer is negative 0.406. So r turns out to be approximately negative 0.406. Let's just do a quick check to see whether or not this actually works. This is 15 negative 4 times negative 0.406. And let's try that now. So let's go to our calculator. 15 to the power of 4 times 0.406, because negative and negative makes a positive. And that is indeed 81.27. Remember, this is my answer is rounded. If I were to take, I'm going to go over here and reapply this answer. Let's say if I take all of the decimal points here and do 15 raised to the power of negative 4 and my answer from before, I guarantee we're going to end up with 81 exactly. And that is exactly what I ended up with, 81. So goes to show, okay, that these answers are rounded. This right here is the exact answer that we were looking for, although very, very abstract, okay? But if we wanted to figure out numerically what that number is, okay, we can just enter that into the calculator and we're done. All right, let's take a look at this guy. So what I have here, okay, is 9 to the negative 5x is equal to negative 72.6. So if I attempt to do the same thing and go through this process, log of 9 to the negative 5x, I take the log of both sides, remember? And log of negative 72.6, the negative 5x comes out in front because of the power rule. I end up with something like this. And x therefore is equal to log of negative 72.6 over log of 9, right? Negative 5 times log 9. And if I do that, log of negative 72.6 divided by negative 5 log of, what was the number again? 9. I end up with something that's imaginary. Actually, I want to change this. I want my only real answers here. So if I do that again, I end up with non-real answers. Okay, there's something wrong. Why is that? Well, if I go back to this, right? If you recall, can we evaluate logs with a negative number? We can't. Remember that? The domain was x is greater than 0, and the range is y is all real numbers. Remember that? So because of this, okay, we cannot take the log of a negative number. And actually, if you go back to the original problem, right, can we take a number, let's say positive 9, which we have here, and raise it to some value of x, or some value, some number? Can we end up with a negative answer as a result? We can't, right? So because of this, okay, there's no solution here. There's no real solution, I should say, okay? There are imaginary answers. However, the answer here is not real. So we say there's no solution here. There's no real solution. Let's take a look at another example. Let's increase the level of difficulty slightly. Not really, though, but it's slight, okay? So we want to solve for the unknown. And what we want to do is we want to very, very strategically get to the unknown, which means we're going to try to isolate the exponential term and then afterwards apply logarithms. So I'm going to add 3 to both sides. So if I do that, I end up with 4 to the 3n is equal to 85. At this point, I'm going to apply the power rule again. And by doing so, the exponent comes out. I get 3n. Log of 4 is equal to log of 85. Divide both sides by 3 log 4. I end up with this, and I can enter this into the calculator. Okay? But I'm not going to do that because I think you guys get the idea. But you enter that into the calculator, make sure you put in the correct parentheses, okay, to get the correct number out of that. Anyway, so that right there is the exact answer. Let's try this last one here, okay? So again, we want to solve for the unknown, which means we have to very strategically get to the unknown by going reverse PEMDAS, and after reverse PEMDAS, we get to the exponential term isolated, and then we're going to apply logarithm. So I'm going to add 10 to both sides. So I get 8 times 11, 6r plus 6 is equal to 76. Divide both sides by 8. I get 6r plus 6 is equal to 76 over 8. I'm not even going to attempt to reduce it because this is all going to go into the calculator anyway. I'm going to take the log of both sides. 11 to the power 6r plus 6 is equal to log of 76 over 8. Apply the power rule. This becomes 6r plus 6. Quantity log of 11 is equal to log of 76 over 8. Divide both sides by log 11. I end up with 6r plus 6 is equal to log of 76 over 8 over log of 11. And subtract 6 and divide by 6. So 6r is equal to this whole thing plus 6 or minus 6. And finally, r is equal to this whole thing divide by 6 or multiply by 1/6. Okay, and you would have to enter that into the calculator. But make sure you apply the orders of operations and place in the correct parentheses in the correct manner.